I would like to introduce and welcome our resource person, Samarth Kulkarni sir, Embedded System Engineer, Bangalore. Working as an embedded system engineer, having experience with embedded software, hardware, microcontrollers, and Texas Instruments Software Organization. At Gate Technologies Private Limited, Bangalore, 2021 present.
His work experience are working on Texas Instruments 16 and 32-bit microcontrollers and ARM architecture. Experienced with Texas Instruments, Code Composer Studio and Energy IDE. Embedded communication protocols. Conducted webinars on embedded system and Internet of Things. Conducted off-campus and online trainings in the field of embedded system, communication protocols and IoT. Has trained 500 plus students and faculties under our training programs on various fields. Recently conducted trainings at MBJ College of Engineering, Dr. AIT Institute of Technology, Bangalore, ACS College of Engineering, Bangalore, and Avinash Lingam Women's College, Tamil Nadu, etc. Project handle. Smart agriculture system using IoT. Research and development on communication protocol using TI microcontroller educational qualification. Completed Bachelor of Engineering degree from ACS College of Engineering, Bangalore, Karnataka. So the stage is open for you, sir. Please.
Yeah, okay, thank you. So I hope my screen is visible for everyone, right?
It's loading, sir.
Yeah. So now is it visible, my screen?
Yes, sir.
Yeah, okay, thank you.
Sir, participant list visible, sir.
Sorry.
Presentation not visible, sir.
Okay, okay. 1 second, sir. Now is it visible, sir?
Yes, sir, visible, sir.
Yeah, thank you, sir. So good morning, everyone. So in this webinar, we are just looking to two important technology such as embedded system and Internet of Things. So why I'm telling these two are important technology, because nowadays everything is going to automate. So if the things are going to automate, then we should be aware of Internet of Things technology. So if we are learning IoT technology, then we should be aware of embedded system, because embedded system is a base for the IoT. So first we will see embedded system, then we'll just move into IoT. So these are my today's outlines: embedded system, then importance of embedded system, then what are the applications of embedded system, where it is used, then block diagram of embedded system, then how to choose a microcontroller for embedded system. Then we'll move into IoT, that is industrial revolution, then introduction to IoT, then building blocks of IoT, then different applications of IoT, then TI microcontrollers. So before going to embedded system, let us understand some concepts. So when we talk about computing system, there are two types of system. One is general purpose system and one more is embedded system. So embedded system is also called as special purpose system. So in the name itself we can understand that. So general purpose system is meant for like a multiple task, and embedded system or special purpose system is meant for only particular or specific task. The example for general purpose system is desktop or laptop, and example for special purpose systems are like calculator, washing machine, microwave oven, refrigerator, then TV. So these are the comes under embedded system. So already we have general purpose system, then why do we need embedded system? That is very very important question. So we'll just learn in further slides. First, let us understand what do you mean by embedded system. So embedded system is a combination of hardware and software which is designed to perform specific tasks. So as I said, this embedded system is also called as a special purpose system. So which means these systems are meant for only a particular or specific task. So it is a combination of hardware and software. So here some kind of hardware like a CPU, memory, then peripherals or components. So if the components has to run by itself, so we need a software. Here software is nothing but a piece of code. So that's why embedded system is a combination of hardware and software, and which is designed to perform a specific task. So you can see here, so embedded microcontroller and microprocessor are used to design an embedded system. So this is the microprocessor or microcontroller IC, integrated circuit. So at this side we are connecting like inputs such as switches or buttons, and a microcontroller microprocessor will process the data and it will give some desired output. And at the output side we are connecting some actuators like a DC motor, stepper motor, or LED, or 7 segment or LCD display, etc. So this is the definition of embedded system. Then you can see embedded system in like a larger mechanical system or electrical system. The best example for larger mechanical system is car. So in the car we can see the embedded system like a GPS tracker, then ABS, anti brake locking system, then airbags, etc. So these are the example for embedded system. Then next question is why do we need embedded system? So I'll just differentiate between like a general purpose system and embedded system. So already we have a general purpose system like desktop or PC. Then why do we need embedded system or special purpose system? So these are the few reasons why we go for embedded system rather than like general purpose system. So the first reason is dedicated hardware. So in the embedded system we can choose the hardware according to our applications, whereas in general purpose system, so we can't choose the hardware according to our applications. For example, if we are buying like a desktop or PC, along with that we have to buy like keyboard, mouse, then CPU, etc. So we can't choose like hardware components there. So in the embedded system we can choose the hardware component according to our applications. Like for example, if you want to like so if you are working with some sensors, then we need ADC peripheral. So if you are controlling some DC motor or stepper motor, then we need a PWM peripheral. So here we can choose the hardware component according to our applications. And next reason is size limitation. So we can see the size of the general purpose system is huge. So whereas embedded the size of the embedded system is very less compared to general purpose system. So that's why we go for embedded system. The next, low power consumption. So when we talk about power consumption, so embedded system requires very less amount of power. Like for example, like 5 volts or 3.3 volts. Okay, 5 volts is the maximum. I hope you have heard in like in Arduino Uno. So the maximum operating voltage is like 5 volts. In some other microcontrollers we can see 3.3 volts also, whereas general purpose system takes more voltage than the embedded system. Then these embedded systems are real time performance, so we can use these systems in real time applications. and next reason is low cost. So compared to general purpose system, embedded system is a less cost. For example, for if you're buying like any general purpose system like desktop or PC, so like the cost of desktop or PC is like more than 30,000, whereas embedded system like 3,000 like that. Okay, so that's why these embedded systems are less cost compared to general purpose system. So these are the few reasons why we go for embedded system. The first reason is dedicated hardware, then size limitation, then it will take like less amount of power, then these embedded systems are used in real time applications, then low cost compared to general purpose system. Next, so these are the few applications of embedded system. So we can see embedded system in household appliances like a refrigerator, microwave oven, TV, etc. Then medical industry, ECG, then digital camera, then aeroplanes, then robotics, then military applications for navigation purpose. So these are the few applications of embedded system. Next, this is the block diagram of embedded system. So here a CPU is the heart of an embedded system. So it is responsible for executing like programs and processing the data. So we need a here CPU or processor. Then so at this side, as I said before, so we are connecting some kind of like inputs like sensor or switches or keypads. So if you are connecting sensors, then so those are analog sensors. First we need to convert to from analog to digital. So CPU can understand only binary numbers, ones and zeros. So that's why we need to convert from analog to digital. So that's why here ADC conversion, then CPU will process the data and it will produce some outputs. So at this side we are connecting like at output side we are connecting actuators. So for that again we need to convert from digital to analog. For that we are using digital to analog conversion. Not only these two peripherals, so PWM peripherals, then timers, GPIO peripherals, etc. Then so here we need a memory to store the code and program. Then we need a software in the sense a piece of code. So if the hardware components has to run by itself, we need a software or piece of code. Then human interface. So as I said before here, human interface such as switches and keypads. So this is the typical block diagram of embedded system.
Sir,
Huh?
sir, slide not changing, sir.
No sir.
No, sir.
No, which slide is
It's
there, sir?
only first slide. Till now, first slide only, sir. This one visible.
First slide.
Yes, sir.
Okay, so wait, give me a minute, sir.
Yes, sir. Now visible, sir.
No visible, sir.
Yes, sir.
So I hope you have cleared about why do we need embedded system. So these are the few reasons: dedicated hardware, then size limitation, then low power consumption, then these systems are used in real time applications, then low cost. Okay, so these are applications of embedded system. So now it is visible, sir. Slide like now it is
Yes, sir.
changing, right?
Visible, sir.
Yes, sir. Okay, thank you. So these are the applications of embedded system. Embedded system used in household appliances, then in medical industry, then digital cameras, aeroplanes, then robotics, then military applications for navigation purpose. And this is the typical block. So this is the block diagram of embedded system. So here we have CPU or processor to process the whole data. So if you are connecting any sensor, then it should be like it has to convert to like a digital, because CPU can understand only binary numbers, ones and zeros. That's why here we have A to D converter. Then it will produce some output. So at output side, we are connecting some actuators like DC motor or stepper motor, LED, LCD display, etc. So for that, we need to convert from analog to digital. For that, we are using digital to analog conversion. Not only these two, like different peripherals, PWM peripherals, then GPIO peripheral, etc. And so here we need a memory. So memory is for storing code and data. Okay. So here, when you talk about memory, here there are two types of memory: RAM, random access memory, and read-only memory. So in read-only memory, we are storing program or code, and in random access memory RAM, we are storing data. And here we need a software. So when you talk about software, which is like it's a piece of code. So the hardware components like A to D or CPU or like D to A or any other peripherals has to run by itself. We need a piece of code or software. Then human interface. So here we need a human interface such as switches or keypads, buttons, etc. So this is the block diagram of embedded system. Then, so as I said, like microcontroller and microprocessor are used to design an embedded system. So now we'll discuss about only microcontrollers. So microcontrollers is also called as mini computer because it has in on chip CPU and on chip, like sorry, inbuilt memory, then inbuilt peripherals, etc. So that's why it is called as mini computer, whereas microprocessor has only CPU. So for and remaining other peripherals like memory and other peripherals, we need to connect externally for the microprocessor. So in the microcontroller, we have inbuilt CPU, then inbuilt memory, then inbuilt peripherals. That's why it is called as mini computer. And microcontrollers come up with different word lengths. So here word length in the sense 8-bit microcontroller or 16-bit microcontroller or 32-bit microcontroller. And depending upon the word lengths, cost will vary. So if you are purchasing 32-bit microcontroller, the cost is like so little bit high. So if you are purchasing a 16-bit microcontroller, the cost is less compared to 32-bit microcontroller. And here we have two ICs. So this IC is called as a dual inline package. So it has two sides of pins, and this is like a quad packaging. So it has four sides of pins. So if you want to more pin, then you can go for like a quad packaging. So if you want less pins in the IC, you can choose dual inline IC. Then what does basic microcontroller consist of? So as I said, microcontroller has inbuilt like a CPU, then memory, then some peripherals like PWM, ADC, GPIO, timer, etc. So here CPU, it is responsible for transferring the data from the to the memory and to the peripheral. Then external oscillators. So here oscillator is used for producing frequency for our whole system. So here we have oscillators, then on-chip memory and on-chip memory, RAM and ROM, then IO ports, so input output ports, then interrupt controller. So it may be a software interrupt or hardware interrupt. So here we need interrupt controller for controlling external interrupt or software interrupt. Then here we have peripherals like timers and counters, etc. Then to transfer the data, we need a data bus, and for accessing the data from the memory, so we need a address bus and serial ports for communication. So in the microcontrollers, we have communication protocols such as UART, I2C, then SPI, CAN protocol, etc. So these are the basic hardware components which are present in the microcontroller. Then, so in the market we have different types of microcontrollers. Then how to choose microcontroller for embedded applications? So first we need to choose the microcontroller. So with a word length. So as I said before, word length in the sense 8-bit microcontroller or 16-bit microcontroller. So the difference between 16-bit and 32-bit microcontroller is, so if you are purchasing 16-bit microcontroller, so we can transfer 16-bit of data at a time. So if you are purchasing the 32-bit microcontroller, so you can transfer 32 bit of data at a time. So that is the difference between like a 16-bit microcontroller and 32-bit microcontroller. Then speed. So here speed is nothing but clock frequency. So some microcontrollers are having a less speed, so which tells us like a speed of the processor or speed of the CPU. So for example, if you can take like Arduino Uno. So Arduino Uno is the speed of the Arduino Uno is 16 megahertz, which is very less. So if you take like a Texas Instrument tools, so I will, for example, like a TIVA microcontroller. So the operating frequency is 80 megahertz. Okay, so you can see the difference. 16 megahertz is for like Arduino Uno, then 80 megahertz is for like TIVA microcontroller. So here you need to choose the microcontroller which is having more speed. Okay, then packaging. So as I said, while choosing microcontroller, we need to see the packaging also, like a dual inline package or quad packaging. Then power consumption. So power is the important factor while choosing the microcontroller. So some microcontrollers like having 5 volts maximum operating voltage. Then some microcontrollers are having like a maximum operating voltage is 3.3 volts. Okay, so based upon your applications, so you can choose the microcontroller. Then amount of on chip memory, then on chip peripherals requirement. So if you want to like ADC and PWM peripheral, then you can go for that microcontroller. If you want more peripheral, then you can switch for other microcontroller which is having more like features. Then depending upon the word length and the memory, the cost will vary. Then while choosing microcontroller, so we have to see the like availability of development tools like assembler, then compiler, then IDE. So IDE is nothing but software. So this is about like embedded system. Then we will just move into IoT. So before moving into IoT, let us understand industrial revolution. So here we have 4 different industrial revolutions such as industry 1.0, 2.0, then 3.0, then 4.0. So industry 1.0, which was started in 18th century. Then what was there before 18th century? So before there was nothing. So human were using their own hands for manufacturing weapons, then clothes, then food, etc. So if they want to transfer like from one thing from one place to another place, they were using animals. With the help of animals, they were transferring some things from one place to another place. So after 18th century, industry 1.0 came into existence. So in the industry 1.0, some mechanical parts came into existence. With the help of mechanical parts, human were doing some other task. And also steam engine came into existence in 18th century. So the best example for steam engine is like trains. And before in cars, then in ships, steam engine were used. After that, industry 2.0 came into existence in 19th century. So in industry 2.0, electrical energy came into existence for mass production, and also assembly line came into existence in the uh, industry 2.0. So that is in 19th century. Then after that, industry 3.0. So in industry 3.0, some automation or some computers came into existence. Then PLC, programmable logic controller, then some electronic devices came into existence. So in industry 3.0, user was programming the particular machine. So a particular machine, according to the program, machine were doing some task. So according to the program, so you can see in industry 3.0, which was a wired connection between like a user and machine. Then industry 4.0. So today we are living in industry 4.0. So here embedded system, then internet of things, then artificial intelligence came into existence. So here also same thing, user is going to program the particular machine. So according to the program, machine is doing some other task. So in the industry 4.0, which was full of wireless technology. So you can see in the industry 3.0, which was a wired technology, then industry 4.0, which is a full of wireless technology. Okay. So here IoT and artificial intelligence technology came into existence. Then, so now what is an IoT or Internet of Things? So here there are two terminologies. One is things and another is internet. So when you talk about things, it can be anything. It can be a pen, paper, table, chair, or mobile. Anything you can take. Then internet. So we are using internet day to day life. So if you combine these two terminology, so you can define internet IoT in your own words. So I'll just combine these two words, internet and things. So we can connect any things or any objects to the internet, so that we called it as internet of things. So if you want to like particular definition, so any physical objects that are embedded with sensor, then microcontroller, then software, then and are able to connect to network via internet, that we call it as internet of things. Okay. So so once it is connected to the internet, so that device can share the data to the cloud, or device can share the data each other, etc. So once it is connected to the internet, then that device is called as smart device. Okay. So I hope you have heard about smart TV, then smart mobile, then smart laptop, then smart TV, etc. So once the device is connected to the IoT or internet, so that device is called as smart device. Then so these are the some building blocks of IoT. So here we have four different building blocks. So first one is smart thing. So as I said, once the device is connected to the like internet, then that device or that thing is called as smart thing. So here we can connect a non-smart device also, non-smart device also. So for example, door. So we can door is a non-smart device. So if you are connecting some microcontrollers, then sensors to the door, so and we can connect that door to the IoT or internet. So after that, that device is called as smart device or smart thing. Then here next block is gateways. So here we need some wireless technology such as Wi-Fi or Bluetooth or LoRa, Zigbee, etc. So these are the wireless technology to transfer the data wirelessly. Then middleware. So here middleware is nothing but a cloud. When you talk about IoT, so memory, storage memory, storage device is called as like a cloud. So in the cloud, we are storing some kind of data. Then next is applications. So if user wants to see the data which is available in the like a cloud, so user can see the data through applications. Okay. He can see the data in mobile phone or laptop, etc. So these are the some building blocks of IoT. Then so these are the some basic elements of IoT. The first one is connected device. So here if you like for example take a again door. So door is a non-smart device. So first so now we can't connect to internet. So first that door embedded with some sensor and microcontroller, then software. Once it is connected microcontroller and sensor, then we have to check whether the microcontroller is having a Wi-Fi module or not. So if the microcontroller is not having a Wi-Fi module, then we need to connect externally. So without Wi-Fi, we can't connect to internet. So while choosing the microcontroller, so you have to check whether this microcontroller is capable of connecting to the internet or network Okay, so if Wi-Fi module is not present, then we can't connect to internet. Okay, so if the Wi-Fi module is present, so we can easily connect to the internet. So that's why while choosing the microcontroller, we have to check whether this microcontroller is having the inbuilt Wi-Fi module or not. If not, so we need to connect externally. So first element is like connected device. Next is central control hardware. So here we need a controller to control the whole data, or to send the data to the cloud. So we need a microcontroller or microprocessor. The next element is data cloud. So here we need a cloud, that is nothing but storage device. Okay, then user interface. So here we need a user interface like applications. Okay, so how our mobile phone having like applications, so here also we need like some kind of applications. Then network interconnection. So as I said before, so if the internet connectivity is not there, so we can't connect any device to the internet. So that's why network interconnection is also an important factor while talking about IoT. Then system security. So here some clouds will provide system security so that no one can access our data. For example, our for emails and for WhatsApp, we are like providing some patterns or lock like that. Here also some kind of clouds will provide some security, so no one can access our data. So these are the some basics elements of IoT. Then applications of IoT. So these are the some applications of IoT. First one is smart home. So in smart home, you can like control like a light or door or bulb, etc. Then in healthcare industry, so patient monitoring system. Then smart agriculture. Then smart cities. So in smart cities, like traffic management, then smart parking system, then smart street light, etc. So these are the examples for like smart cities. So this is about IoT. So if you have any query, you can ask. Hello, am I audible?
Yes, sir.
Yeah, I hope now it is clear, right? Embedded system and IoT. So if you have any query regarding these two technology, you can just ask.
Dear participants, if any queries, please ask our sir, or else please post your queries in chat box.
Okay, so now we'll see some like here I have explained some microcontrollers which are from the Texas Instrument. So these controllers are used in industry. More than 150 industry are using these microcontrollers. So if you take like Arduino Uno, that is like a basic microcontroller. So in the industry, so these microcontrollers are using like Texas Instrument tools. So the first one is TM4C123GH6PM microcontroller. So you can see the features of this TIVA microcontroller. So it has like ARM Cortex M4 processor, that is 32-bit microcontroller, and operating frequency. So operating frequency is 80 megahertz. So which tells us like processor speed or CPU speed. Then memory, it has 256 KB of flash memory, then 32 KB of SRAM. So flash memory is for storing programs, then SRAM is for storing datas. Then it has ADC, PWM peripheral. So it has two ADC module and two PWM modules. Then this microcontroller has like a communication protocol such as UARTs, then I2C, then SPI. So it has total 8 UARTs, then 4 I2C, then 2 SPI. Then it has onboard RGB LED, red, green, blue LED, then 2 push button, then 40 pins are available on the launchpad. So the right side 20 pins and the right side 20 pins. Total 40 pins are available on the launchpad. Then it has like oscillators which produces 16 megahertz for our microcontroller. So this is the like features of TIVA microcontroller. And next is MSP430 F5529 microcontroller. So which is a like ultra low power consumption microcontroller. It will take very less amount of power compared to TM4SIM 123 microcontroller. And you can see the processor. So it has like a 16-bit RISC processor and operating frequency 25 megahertz. So you can see the difference between these two microcontroller. The operating frequency is here 25 megahertz, whereas in TIVA it has 80 megahertz. So you can see the huge difference here, 25 megahertz and 80 megahertz. So these are the major difference between like in microcontrollers. And flash memory, 120 KB of flash memory to store the program, then 8 KB of SRAM. Then it has some peripherals like ADC, PWM, then timer, then communication protocols. It has only 2 UARTs, whereas in previous microcontroller it has 8 UARTs, then 2 I2C, then 4 SPI. Then it has like onboard red and green LED. So whereas in previous microcontroller RGB, red, green, blue. So it has only 2 LEDs, red and green, and 2 push button, and it has 46 pins on the launch pad. So this microcontroller will take like a less amount of power compared to other microcontrollers in the Texas Instrument tools. The next, this microcontroller is like MSP430 to P401R. So this is the name of the microcontroller, mixed signal processing 432 P401R microcontroller. So it has like a processor is ARM Cortex M4F processor, then operating frequency. So you can see the operating frequency 48. Then memory, 256 KB of flash memory to store the program, and 64 KB of SRAM. It has like ADC. So here 14-bit ADC. So you can see in the previous microcontroller 12-bit ADC. So these are the different features between microcontrollers. It has 14-bit ADC. Then it has PWM, then 2 UART, 2 I2C, then it has only one SPI. So whereas in previous microcontroller, we have 4 SPI in the like particular this microcontroller, whereas in MSP432, we have only one SPI. So these are the communication protocols. Then it has total 4 LEDs. So RGB, red, green, blue, and another is red LED. It has total 4 LEDs, then 2 push buttons. Then it has like 46 pins on the launch pad. Then, so these microcontrollers are used in like embedded applications. So TIVA microcontroller, then MSP430, then MSP432. So all the microcontrollers are not having like inbuilt memory. So if it is not having inbuilt memory, then we can't connect to internet. So if you want to use these 3 microcontrollers, TIVA microcontroller, then MSP430, then MSP432, if you want to connect these 3 microcontrollers to the IoT, then we have to use external Wi-Fi module. So that is CC3100 Wi-Fi booster pack. So you can connect this booster pack to this particular microcontroller, and after connecting that one, so you can easily connect microcontroller to the IoT. Okay. So this is the Wi-Fi booster pack. So you can connect to any microcontroller. So TIVA microcontroller or MSP430 or MSP432. And next is CC3200 microcontroller. So it has like 32-bit ARM Cortex M4F processor, then operating frequency is 80 megahertz. Then it has inbuilt Wi-Fi module. So here no need to connect external Wi-Fi module. So in the microcontroller itself, uh, Wi-Fi module is available. So no need to connect external Wi-Fi module. So easily you can connect this microcontroller to IoT. Then it has like a 256 KB of RAM. Then communication protocols like UART, SPI, and I2C. It has like a peripherals. It has like a GPIO peripheral, then PWM peripheral, then watchdog timer, then ADC module, and 40 megahertz of like a crystal oscillators. So these are the some features of CC3200 microcontroller. And next, so this is one kit which is manufactured by our company, Edget Technology. So the name of the kit is IoT for You kit. So in the IoT for You kit, we have kept four different microcontrollers such as Arduino Uno, then Raspberry Pi Pico, then ESP32, then STM32. So we have kept microcontroller in such a way that so students can learn from beginning. So as I said, Arduino Uno is a basic microcontroller. So next, so if you work on, so you can easily work on with like Arduino Uno microcontroller. Once it is done, you can switch for ESP32. So ESP32 has inbuilt Wi-Fi module and Bluetooth module. So here you can like build some IoT applications using wireless technologies. Then once it is done, so you can go for STM32, or if you want to learn like a different language or a different IDE, then you can use Raspberry Pi Pico. So Raspberry Pi Pico uses Python programming language, whereas like Arduino Uno, then ESP32, then STM32 uses embedded C programming language. And apart from microcontrollers, then here we have kept four different sensors. One is MPU 6050, that is nothing but a gyroscope and accelerometer sensor. Then pressure sensor, BMP 280 sensor. Then DST11, that is humidity and temperature sensor. Then one port, so A to D converter. So these are four different sensors. Then so here we have given provision for connecting Raspberry Pi 3 or Pi 4 board. So if in your college, if you are having Raspberry Pi 3 or Pi 4 board, so you can connect to these pins. And here we have given provision for connecting NB-IoT or Zigbee module. So in this kit, like we have kept both wired technology as well as wireless technology. So one is Zigbee module, then GSM module, then LoRa. So one of the booming technology nowadays, that is LoRa, long range uh, sensor. Then it has inbuilt Wi-Fi module and Bluetooth module. So these are the wireless technology. Coming to wired technology, so here we have kept like RS-232 converter, then RS-485, then CAN protocol. And all the microcontrollers are having a UART protocol, then I2C protocol, then SPI protocol. So these are the wired technology. Then on the kit, we have kept two relays. If you want to control 230-volt appliances, so you can control through relays. So here we have kept two relays, and in the kit we have kept two RGB LEDs. So one RGB LED and another RGB LED, and two user accessible switches. And also we have kept like a TFT display in the IoT for you kit. So if you want to display any data, for example temperature data or gyroscope or accelerometer data, so you can easily print on the TFT display. So this is about IoT for you kit. Then thank you. So if you have any doubts regarding like embedded system or IoT or any tools, so you can ask.
Sir, once re-explain the block diagram of embedded system.
Block diagram of embedded system. Okay.
Yes, sir.
So in the microcontroller and microprocessor are used to design an embedded system. Okay, so I hope you have used any microcontroller, for example 8051 or Arduino Uno microcontroller. So I will take one example like Arduino Uno microcontroller. So in Arduino Uno microcontroller, we have Atmega 328P processor. So that is nothing but a CPU. So it is responsible for transferring the data or processing the data at Mega 328P in the Arduino Uno microcontroller. So that is nothing but CPU or processor. Then apart from that, it has inbuilt some peripherals like A to D converter or D to A converter, ADC or DAC. Okay, so if you are connecting any sensor to the Arduino Uno microcontroller, then we have to use A to D converter or ADC module. Why? Because CPU can only understand binary numbers, ones and zeros. So these are analog sensors. So analog sensor will convert it into digital here. So ADC module will convert from analog to digital. Then it will give to CPU. Then here it will process the data and it will produce some output. Okay. So if you are connecting any actuators, for example, like a LED or a LCD display or a stepper motor, DC motor, servo motor. So again, we have to convert from digital to analog. For that, we are using like a DAC, digital to analog converter. So this module will convert from digital to analog. Then it will give to actuators or any actuators. So these are the some peripherals. Not only these ADC and DAC. So Arduino Uno microcontroller has some like a PWM module, then timer, etc. And so in Arduino Uno microcontroller, we have like a memory to store the program and code and software. So here software in the sense a piece of code. If these modules has to run by itself like ADC module or DAC or timer or PWM, so we need a piece of code that is nothing but a software and human interface. So in the Arduino Uno microcontroller, we have like a switch button to control actuators. Okay, so here we need like a human interface such as switches or keypads. So this is the typical diagram of embedded system. I hope now it is clear, right?
Yes, sir. Thank you, sir.
Yeah. So any other questions? About embedded system or IoT or any other Texas Instrument tools or IoT for you kit? So any questions?
Dear participants, if any queries, please ask the resource person or else please post in chat box. Sir, maybe no questions, sir.
Okay, sir. Then fine. So if you have any other query, you can just ask. Otherwise, so we can wind up this session.
Okay, sir. Thank you for delivering nice session, sir. Very valuable session.
Okay, thank you, sir.
Thank you for our coordinator, Dr. Subodh sir, for arranging the wonderful session. Finally, we would like to conclude this session by thanking our sirs. Thank you, one and all.
Thank you, sir.
Thank you, sir.